Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity. Use LLDP to map a network. Before coming to this activity, friends, if you like to get any CCNA support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get these type of technical videos in future, consider subscribing. And don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Back to our activity. So here we can see addressing table, and this addressing table is incomplete. Also we can see the topology here, admin-pc, S1, edge. Also we have this remote branch office inside this cloud. And it looks almost our previous packet tracer activity, in that we used CDP. Here we use LLDP. Here we can see the objectives. Map a network using LLDP and SSH remote access. We will go through the background. A senior network administrator requires you to map the remote branch office network and discover information about all of the devices in the network. You must record all of the network device names, IP addresses, and to mask and physical interfaces interconnecting the network devices. To map the network, we will use SSH for remote access and the link layer discovery protocol, that is called LLDP, to discover information about neighboring network devices. Because LLDP is a layer 2 protocol, it can be used to discover information about devices that do not have layer 3 connectivity. We will record the information that to gather to complete the addressing table and provide a topology diagram of the remote branch office network. We will need the IP address for the remote branch office, which is 209.165.200.10. The local and remote administrative usernames and passwords are given here. Local network username is admin01 and password is here. Also we can see remote branch office network username, it's RBO admin, and here is the password. We will go through the instructions. Part 1. Use SSH to remotely access network devices. In part 1, we will use the admin-pc to remotely access the edge gateway router. Next, from the edge router, we will SSH into the remote RBO office. On the admin-pc, open a command prompt, then SSH into the gateway router at 192.168.1.1 using the username admin01 and the password. So we have to give this command like this: SSH space -L, then the username, then the target. Then we have to press enter and it will prompt for the password. We have to give this password. We will SSH into this router edge using this admin-pc. Click on that. We'll go to desktop, command prompt, and here we will give that SSH-L, then the username and the target IP address. Then we have to give the password. Paste here and press enter. And we can see now we are in this edge router. We are in a privileged exec mode. They given a note. Notice that you are placed directly into privileged exec mode. This is because the admin01 user account is set to privilege level 15. Yeah, already we have seen that. The edge router was previously configured to use CDP. Switch S1 has already been configured to use LLDP. Issue the show CDP command to verify CDP is currently active. Disable CDP by issuing the following command. So no CDP run. We will disable this CDP using this command no CDP run. Coming to this admin PC, we will go to global configuration mode, conft, that is configure terminal, and here we have to give a no CDP run. LLDP can be configured to both transmit and receive on a specific interface. Configure Edge so that it receives LLDP messages from S1 but does not send a message to S1 for security purposes. Enable LLDP. So we can see in Edge we have to enable LLDP run, then go to interface G0/0 and give no LLDP transmit. Coming to our admin-PC. Okay, here we will give a LLDP run. Oh, here now we are in privilege exit mode. We have to go to global configuration mode, conf t or configure terminal, and here we will give that LLDP run. Then we will go to interface, it's a G0/0, and here we can give a no LLDP transmit. Use the show LLDP neighbors command to verify that Edge is receiving messages from S1. Okay, we will give this a command, show LLDP neighbors. Okay, here we can see this SSH is closed. So here again we will give this and the password. Okay, here we will give that command, show LLDP neighbors. And here we can see device ID, local interface, capability, and port ID. Connect to S1 with the SSH from Edge router using the admin01 credentials. Issue the show LLDP neighbors command. Notice that S1 did not receive information from the Edge. So we have to give this command SSH space -L space admin01 with this address 192.168.1.2, the IP address of this switch S1. So just I will copy that. Coming to admin PC, here we will give that, and it's SSH-L. Here we have to give a -L, admin01, then the target, password, okay, and here we will give that command, show LLDP. Let me put a question mark, neighbors. And here we cannot identify any neighbors. Exit from the connection with S1 to return to the Edge router CLI. Use the show IP interface brief and show interfaces command to document the Edge router's physical interfaces, IP addresses, and to mask in the addressing table. So we have to give these commands, show IP interface brief and show interfaces. So coming to admin-PC, exit so that we are back to Edge. Here we will give the command show IP interface brief command, and here we can see in this router Edge we used the gigabit Ethernet 0/0 and a serial 0/0/0. Here coming to our addressing table, here we can see those interfaces G0/0 and serial 0/0/0. Here we will get the IP address of serial 0/0/0. Just I will copy this address and paste here. Also we have to get its subnet mask. We will use show interface. We can give a serial 0/0/0, and here we can see its internet address. Also we can see the prefix /30. That means subnet mask is 255.255.255.252. Here we can see we have to identify local interface and the connected neighbor for this G0/0 in this edge router. Coming to this PC, here we can give the command show Lldp neighbors, and here we can see this device S1. Local interface is G0/0. That means the interface in this router edge, and it is connected to gigabit Ethernet 0/1 in this S1. So just I will copy S1 to G0/1. Here we can give G0/1 to S1. From your session with the edge router, connect with the SSH to the remote RBO office at 209.165.200.10 with the username RBO admin and the same password used for admin01. So we have to give this SSH command. So here we have to give SSH-L, then the username, then the target. We have to get the password. And we can see now we are in RBO-edge. After connecting to the remote RBO office at 209.165.200.10, what piece of previously missing information can now be added to the addressing table above? So here we have seen, now we are in RBO-edge. So we got this device name here. So that can be added in our addressing table. And here we can see this SVI. This is SVI of S1. So here we can give S1. And it's subnet to mask. Here we can see this IP address is from the same subnet of this address. So we can use this subnet to mask. Or even we can verify it. If you go to this S1, we can verify that. Next, we will go to part 2. Use Lldp to discover neighboring devices. You are now remotely connected to the RBO-edge router. Using Lldp, begin looking for the connected network devices. Issue the show IP interface brief and show interfaces commands to document the RBO-edge router's network interfaces, IP addresses, and subnet masks. Add the missing information to the addressing table. We will give these show commands. Show IP interface brief, and here we can see these two interfaces are up, gigabit Ethernet 0/0 and gigabit Ethernet 0/1. Also we can see its IP address G0/0 and G0/1. We can merge these two cells. Also given the IP address here, we will copy the IP address of a gigabit Ethernet 0/1 and paste here. Also we can get its subnet mask. Show interface. First of all, we will go to G0/0. And here we can see it's a prefix given /30. We can copy this subnet mask. Then we will go to G0/1. We have to give a show interface G0/1. And here we can see prefix /30. Security best practice recommends only running Lldp when needed. So LLDP may need to be turned on. Use a show LLDP command to test its status. So we will give this a show LLDP command. Show LLDP, and we can see it says LLDP is not enabled. You need to turn on LLDP, but it is a good idea to only send LLDP information to internal network devices and not to external networks. Discover which interface is connected to the internet by issuing the command show IP interface brief. Enable the LLDP protocol and completely disable LLDP on the interface that is connected to the internet. Coming to admin-PC, we will give that a show command show IP interface brief, and here we can see the public IP address they configured for the interface gigabit Ethernet 0/0, which is connecting towards the ISP. Here we will enable LLDP, and we have to go to that interface G0/0, which is connecting to the ISP, and we will disable this LLDP. Here we can see the command no LLDP transmit, no LLDP receive. Coming to this admin-PC, configure terminal. Here we will give a LLDP run. Then we will go to interface, it's a G0/0. Here we have to give a no LLDP transmit, also no LLDP receive. Issue a show LLDP neighbors command to find any neighboring network devices. They given a note LLDP will only show connected devices that are also running LLDP. We have to give this command show LLDP neighbors. Exit show LLDP neighbors. Here we can see one device RBO-firewall. Just we will copy this device name and we will add in this addressing table. Okay, and also we can see local interface, that is the interface of this router RBO-edge. It's a G0/1. Then it's connected to this G0/0 in this RBO-firewall. Is there a neighboring network device? What type of device is it? What is its name? On what interface is it connected? Is the device IP address listed? Record the information in the addressing table. Yeah, just now we explained that. So here we have seen this device RBO-firewall, and we have seen it's a router. We can see capability, R is for router. And also we can see it's connected to this port G0/0 in this RBO firewall. But here we cannot see any IP address for this RBO firewall. Use the show IP root command to determine the address of the device that you found with the show LLDP neighbors command. Based on the information provided about the local address, the routing table, and the prefix length of the network, use that information to determine the neighbor address. We will update this local interface and connected neighbor for this interface G0/1 in this router RBO-edge. Here we can see the local interface gigabit Ethernet 0/1, the interface in this RBO-edge, and it's connected to this device RBO-firewall to the interface G0/0. So just I will copy this device name, the host name, and here we can update that G0/0 to this RBO-firewall. We can give a show IP root command also here. We can see two connected networks. directly connected to gigabit Ethernet 0/1, and here we can see another directly connected network gigabit Ethernet 0/0, and it's a public IP address which is connecting to the ISP. To find additional information from the neighboring device, use the show LLDP neighbors details command. Okay, we will give this a show command, show LLDP neighbors details. What other piece of potentially sensitive information is listed? So we will give this command and we will verify that. Show LLDP neighbor details. So it's a detail, and here we can see the details. We can see port ID, description, system name. Even we can see Cisco iOS software, its name, version. We can see many things here, and we can see they specify the version, iOS name and its version. They given a note here. The current version of packet tracer does not provide the management address of the neighbor device. In this activity, several neighbor device addresses have been provided in the addressing table. Okay, here we can see that. We cannot see the IP address of this device, that is RBO firewall. We cannot see management address, not advertised. So this is what they told here. Connect it to the neighbor device with SSH to discover other devices that may be its neighbors. To connect with SSH, use the same remote RBO office username and password. But here, without the IP address of our router RBO firewall, how we will go to that router? So we have to get the IP address of RBO-firewall. So we can get that here. Let me give a show command, show LLDP neighbors, and here we can see the interface G0/1, the interface of this router RBO edge, and we can see the port G0/0, the RBO firewall port G0/0. We have to get the IP address of G0/1 so that we can identify, or we can get the IP address of this interface G0/0 very easily. So here we can give a show IP root. Here we can see the IP address gigabit Ethernet 0/1. Its prefix is /30. That means we will get only 2 usable IP address from this subnet. And here we can see the IP address of this interface G0/1 in this router RBO-edge. It's 192.168.3.249. So obviously the other side, the IP address will be 192.168.3.250. So just I will copy this, and here we will give SSH space -l. Then we have to give the username. It's RBO admin. Then the target, it's a 250. We have to give the password S3CRE7P@55. Now we can see we are in RBO firewall. After successfully connecting with the SSH, what does the command prompt show? Here we can see it shows this router host name, that is RBO-firewall. You are remotely connected to the next neighbor. Use the show LLDP neighbors command and the show LLDP neighbors details command to discover other connected neighbor devices. Coming to admin-PC, here we will give show LLDP neighbors, and here we can see we have these neighbors RBO edge. Okay, already we have seen that RBO edge. Then we have SW-RBO1. Here we can see the local interface, the interface of this router RBO-firewall, and it's connected to G0/1 in this SW-RBO1. So just I will copy this switch here, and we can see it's connected to G0/1. Okay, perfect. Here we can see it shows the capability B. B means bridge, that is switch. So here again we will give a show LLDP neighbors detail, and here we can see the details. Here we can see RBO edge, but we cannot see the IP address. Here we can see SW-RBO1 software version, and management address not advertised. What type of network devices neighbor this device? Yeah, we have seen it's a switch. Record any newly discovered devices in the addressing table. Include their host name, interfaces, and IP addresses. So we just added this device here. We have to get its IP address and interfaces. So there will be an SVI, okay, and we have to see its interfaces. Before that, here we can see we did not update this RBO firewall, its interface, its IP address, subnet to mask, and a local interface and connected neighbor. So we can identify that from here. Now we are in this RBO firewall. Here we will give the command show IP interface brief. And we can see they used gigabit Ethernet 0/0 and gigabit Ethernet 0/1. Coming to our addressing table, here we will label that G0/1 and G0/2. Also we have to get its IP address. G0/0, just I will copy its IP address. G0/1. Also we have to get its subnet to mask. Show IP interface, it's G0/0. We'll try this. And here we can see internet address, they given the prefix /24. So we can update it. And for this G0/1, we can press up arrow from the keyboard and give G0/1. Here we can see internet address, and given this address 192.168.4.254/25. So we will update that here. 255.255.255. It's 128. And here we can see for this interface G0/0, they given the subnet to mask, they given the prefix /24, but we can see the other side they given /30. So actually there is a mismatch with the subnet to mask. Okay, and here the local interface and connected neighbor, this is G0/1 of RBO edge. Okay, even we can verify this. Coming to admin-pc, we will give this command again, show LLDP neighbors, and here we can see RBO-edge. We can see the local interface, that is G0/0, the interface of this router RBO-firewall, and it's connected to G0/1, the interface of this RBO edge. So that's why we given G0/1 -RBO edge. Also here we can see this router RBO-firewall is connected to SW-RBO1. Just I will copy this to this interface G0/1. So we will update that G0/1 to this switch. Perfect. Add the newly discovered device name next to the SBI entry for address 192.168.4.131. Okay, here they given the IP address for this switch. So just we'll add that here. Okay, that's perfect. Connect to the SBI for address 192.168.4.131 using SSH and credentials used previously. If prompted for an enable secret password, use the same password as used for RBO admin. Use the show LLDP neighbors command and the show LLDP neighbors detail command to discover other connected neighbor devices. Coming to admin-pc, and here we will give SSH space -l. Then we have to give the username. It's RBO admin. Then the target IP address, it's here. You already copied it. And password is S3CRE7P@55. Okay, here we can see now we are in a user exec mode. Here we will give enable. And again, it's prompted for the password. Here also we will give that same password. CRE7P@55. Okay, perfect. We will give the show command, show LLDP neighbors. And here we can see we got two neighbors. One is SW-RBO2 and RBO-firewall. Already we have seen this RBO-firewall. And here we got one more switch. Just I will copy that and paste here. Also we will give a press up arrow and give a show LLDP neighbors detail. Here we can see SW-RBO2, but we cannot see management address. Here we can identify the used interfaces. Show IP interface brief command. Here we can see VLAN address they given, VLAN 1 IP address. They already provided that. And here we can see these three interfaces are up. That is a fast Ethernet 0/24, gigabit Ethernet 0/1 and gigabit Ethernet 0/2. So we will mark all these interfaces here. It's FA 0/24. Then we have a G 0/1 and G 0/2. Here again we will give this show command, show LLDP neighbors, and here we can see these interfaces. G 0/2, the interface of this SW-RBO1, and it's connected to G 0/2 of SW-RBO. So just I will copy this. G 0/2, it's connected to G 0/2 of SW-RBO2. Here we can see this G 0/1. Here in this RBO firewall, we can see G 0/1 SW-RBO1. It's connected to this RBO firewall interface G 0/1. So here we can update that G 0/1. It's RBO dash firewall. What types of network devices neighbor this device? Record any newly discovered devices in the addressing table. Include their host name, interfaces, and IP address. So we already given the details here. Place the newly discovered device name next to the SBI entry for address 192.168.4.132. So we will give this IP address for this SW-RBO2 SBI and give that IP address here. Okay. Connect to the SBI for address 192.168.4.133 using SSH and credentials used previously. Issue command show LLDP. You should receive a message. LLDP is not enabled. That means we have to enable LLDP. I will copy this IP address here. Then coming to admin-pc, here we will give SSH space -l. Then the username, that is RBO admin. Then the target IP address, we already copied it. Password is yes3CRE7 p@55. Okay. Enable yes3CRE7 p@55. Okay, now we are in SW-RBO3. We will give this a show command, show LLDP neighbors, and here we can see it says LLDP is not enabled. Enable LLDP globally as in step C. There is no need to configure transmit or receive options because they are on by default. Use the show LLDP neighbors command and the show LLDP neighbors detail command to discover other connected neighbor devices. Coming to this admin-pc, here we will go to global configuration mode, conft, and here we will give LLDP run. So we enabled LLDP. Now we will exit, then give this a show command, show LLDP neighbors. And we can see the neighbors. We have SW-RBO2, SW-RBO1. Okay, so just I will copy this host name here and I will give SW-RBO3 and we will give its IP address. So we already given that here. Perfect. Okay. Here we can see the neighbors SW-RBO2, SW-RBO1. We can see the local interface. Just I will copy these interfaces here. The interfaces in this switch RBO3 and G0/1. Copy and paste here. Yeah, perfect. Then we can see this is connected to G0/1 in SW. Just I will copy this. G0/1, it's here. G0/1 to this switch RBO2. Then here we can see FA0/24. It is connected to FA0/24 of this switch. FA0/24. Perfect. Clearly we can understand SW-RBO3 and SW-RBO1 is connected using these interfaces. FA0/24 in this RBO3 and FA0/24 in this SW-RBO1. So here we can see we did not update this local interface and connected neighbor for this FA0/24 in SW-RBO1. Now we can update it. It is connecting to FA0/24, connecting to this SW-RBO3. SW-RBO3. Here we will give this show command, show LLDP neighbors detail. Sorry, it's a detail. Perfect. And we can see the details, but here also we cannot see the management address. So let me give show IP interface brief command, and here we can see the IP address of this switch RBO3. So this is already we updated. Okay, and here we can see these two interfaces are up. fast Ethernet 0/24 and gigabit Ethernet 0/1. So we already updated in our addressing table. What types of network devices neighbor this device? Record any newly discovered devices in the addressing table, include their host name, interfaces, and IP addresses. It may be beneficial to reconnect to the previously discovered devices to display neighbors one more time to complete the entire addressing table. Now that all devices are configured for LLDP, draw a topology of the remote RBO office network using the information that you have gathered with Lldp. Here, we did not go to this switch SW-RBO2 using this IP address. So we will try using this address. SSH-L, then we have to give the username, it's RBO admin, then the IP address. Okay, we will give the password S3 CRE7P@55. Okay, here we can see RBO2 enable S3 CRE7P@55. Sorry, S3 CRE. Actually, they're given a complicated password. Yeah. Okay, now we are in privilege exit mode. Here we will give a show LLDP neighbors. Here we have two switches capability B, SW-RBO3 and SW-RBO1, and we can see its interfaces. G0/1, G0/2 in this switch, and we can see its port ID of these neighbors. We will update the details of these interfaces G0/1, G0/2 in this SW-RBO2. So here I will give that. Okay, that's perfect. So here we will give a G0/1 and G0/2. I think I will copy from here. Okay. And we have to identify local interface and connected neighbor. G0/1, G0/1 of this switch. Okay, just I will copy this. G0/1 SW-RBO3, then G0/2, it's connected to G0/2 of SW-RBO1. G0/2 of RBO1. Perfect. Using this addressing table, we can design the topology in this remote branch office. So let me add a computer. This is admin-PC1. Let me give PC1. We cannot give a duplicate name. Then we have a S1. Okay. I will give a S1-1, and we will connect to PC2 FA0/5. Then we have this edge router. We will give the name as edge1. And here we can see it's connected to G0/1, G0/0, G0/1, G0/0. Coming to this addressing table, we can see edge1 serial 000 is connecting to ISP serial 000. So we will add one more router as ISP. So here we have our ISP. Let me give ISP1. We will go to this router edge1, switch it off, and add a serial, because we have to connect to serial to the ISP. In ISP also we have to add this serial interface. Then connect to serial from serial 0/0/0 to serial 0/0/0. Here we can see we got two more routers, RBO-edge and RBO-firewall. So we will add these routers here. Let me give the names. RBO-edge. We will give edge 1, RBO-edge 1, and this is RBO-firewall, firewall 1. Okay. Coming to this addressing table, we can see in this RBO edge G0/0 is connected to G0/0 of ISP. We will choose copper crossover from G0/0 to G0/0. Then we can see G0/1 is connected to RBO firewall, G0/0 of RBO firewall. Again choose copper crossover from G0/1 to G0/0. Now here we have three switches, SW-RBO1, RBO2 and RBO3. And we can see RBO1 is connected to RBO firewall. So we will add three switches here. Okay. We will choose copper straight through. And here we can see this G0/1 is connected to SW-RBO1. Both sides G0/1. Then we have to choose copper crossover because we have to connect the switches. Before that, let me give the names for this. This is RBO1. This is RBO2. And this is RBO3. 3-1 we will give because it won't accept duplicate names. Now we will choose copper crossover. Here we can see this interface FA0/24 in this RBO1 connected to FA0/24 of SW-RBO3. Okay, we can connect that from this switch FA0/24 to this RBO3 FA0/24. Then we can see G0/2 is connected to SW-RBO2. Both sides G0/2. G0/2 to this switch G0/2. Now we can see we have to connect RBO2 and RBO2 and RBO3. Here we can see SW-RBO2 G0/1 to G0/1 of RBO3. Okay, yeah, perfect. Connect G0/1 to G0/1. Using this addressing table, you can assign IP address for all the interfaces and these switches. Perfect. That's all in this activity, that is use LLDP to map a network. Now dear friends, if you get any doubt or any suggestions regarding this packet tracer activity, please comment below, or even you can contact our team using our website. Link you will get from the description below. And if you like our video, give a thumb and share with all your friends. Stay tuned and we will meet again with the next video. Thank you.